Hi, everyone. So today we're going to be looking at solving equations involving complex numbers. Okay, so just before we start, I just want to do a quick recap of what we've gone over last time involving complex numbers. So we know that a complex number z can be written in terms of a real part, x, plus r times an imaginary part, y, where this I is defined as the root of -1. In other words, r squared is equal to -1. Okay, so we said that was the defining feature for this complex number r. Okay, and then we can do all kinds of operations with these complex numbers. So we can add them, subtract them, multiply them, and divide them, just like we can do with real numbers. However, we need to take into account that this complex number has these two parts, and then one of this parts has this I, and we need to remember r squared is -1. So when we're multiplying two complex numbers, we need to keep that in mind. Okay, then we looked at the magnitude of a complex number, or the norm of a complex number, okay, given by the absolute value signs. And this is equal to the square root of x squared plus y squared. Okay, so that was another thing that we could do with complex numbers. Okay, and we also had this other operation, complex conjugate, given by z star, or you might see z bar. Okay, so just different symbols for the same thing. And what we do is we replace I with -r. Okay, we call that complex conjugation. So if z is equal to x plus ry, then z bar or z star, or the complex conjugate of z, is x minus ry. Okay, so that's the complex conjugate of z. Okay, that's pretty much all we need to know to understand equations with complex numbers and then solving for z. Okay, so before you were given equations involving x, say like x squared plus 2x plus 1 equals 0, and you have to solve for x. Now we have equations involving z, okay, the complex number z, and we need to solve those equations for z. Okay, and just remember z is a complex number, so your final answer should have some real part and some imaginary part. Okay, let's have a look at the first equation. So this is number 1, example 1. We have z squared is equal to the absolute value of z squared minus 4. Okay, so what we can do is we can substitute z is equal to x plus ry. Okay, that will just help us in solving for z. So we're going to say z is equal to x plus ry. Since z is any complex number, of course, we can write it as x plus ry. Okay, so let's substitute this in and see what we get. So for the first bit on the left-hand side, we're going to get x plus ry squared. Then we're going to have the absolute value, x plus ry squared minus 4. Okay, now we can just perform these operations because we know how to square a complex number. We know how to take the magnitude of a complex number, and we can square the result. So on the left-hand side, we're going to get x squared plus 2ixy, and then squaring iy is going to be r squared, which is -1, and y squared. So it's going to be minus y squared is equal to the magnitude of x plus ry is going to be the square root of x squared plus y squared. But since we're squaring it, it's just going to be x squared plus y squared. And then we have the -4. Okay, so what we can do now is take everything over to the left-hand side. So that will make the left-hand side some expression with x and y, and the right-hand side will be 0. Okay, so we'll see that that will be quite helpful. So we're going to have x squared plus 2ixy minus y squared minus x squared minus y squared plus 4, and then that's going to be equal to 0. Now on the left-hand side, we've got x squared minus x squared, so we can cancel that. And the remaining terms we can group into a real part and an imaginary part. So the minus y squared, that's going to be minus 2y squared plus 4. All of that is going to be real. So we can have 4 minus 2y squared. We can group that together. And then the imaginary part is the part with the r. So that's going to be plus r times 2xy is equal to 0. Okay, because this result is a complex number. It's got a real part. Let's put that in blue. It's got an imaginary part. Let's put that in green. And we've got that is equal to 0. Now, the 0 on the right-hand side is not the 0 from the real numbers. This is a complex 0. So a complex number 0. Okay, so why do I say complex number 0? Well, we need to think of the 0 as 0 plus r times 0. Of course, the result is just 0, right? However, this makes it a bit clearer with what this left-hand side means. So if this left-hand side is equal to 0 and it's a complex 0, it means the real part must be 0 and the imaginary part must be 0, like we wrote here. This real part is 0 and the imaginary part is 0. Okay, both must be 0 for the right-hand side to be 0. So let's just make a note. Both the real part and the imaginary part must be 0. That's how we get a 0 complex number. Okay, both of them must be 0. So that gives us two equations. One equation for the real part being 0. So we're going to have 4 minus 2y squared is equal to 0. And because we said both parts, so we have an and there, the imaginary part is also 0. So 2xy must be 0. Okay, so now we can just solve these simultaneously to see the possible values of x and y. And once we have the possible values of x and y, that will give us the possible values for z. Okay, so let's do this first part. 4 minus 2y squared, we can divide by 2. So we're going to get 2 minus y squared is 0. That's going to give us y is equal to plus or minus root 2. Okay, so that bit's pretty easy. And then on the other side, 2xy equals 0. So xy equals 0, x equals 0, or y equals 0. Well, for the first part, we said that y could be plus or minus root 2. So it can't be that and 0. So we can get rid of that part. So we know that x is equal to 0 and y can take on those two values. So that gives us the possible values for z. So z is going to be, the real part is 0 and the imaginary part is root 2. So plus I root 2. So you can write it like that to show the real part and the imaginary part, or we can just write I root 2. And that's just saying that the real part is 0 because we're not writing it down. So that's the first solution. And then the second solution is if we take minus root 2. So z is equal to, again, 0 minus I root 2. So you can leave it like that if you want to show both parts, or we could just write minus I root 2. So these are the two possible complex solutions to that equation. So this complex equation has two complex solutions. Okay, so we see there's no real solutions, okay, because z has this imaginary part to it. So it's a complex solution. Okay, so that is the basic method that you'll be using to solve these types of equations. So if it's a bit complicated like this, it might be easier to substitute z is equal to x plus ry, because that's a general complex number. Then you can substitute in. You can get something like this with the real part plus the imaginary part equaling 0. If that is to be equal to 0, we know that the real part must be 0 and the imaginary part must be 0. Okay, that's going to give us some set of equations to solve simultaneously. So you solve them, you get your possible x values, your possible y values, you put that together, and that gives you your possible z values or your possible complex solutions. Okay, so whatever your x and y are, you can use that to recover what z has to be. Okay, let's have a look at one more example for today. Example 2. Okay, so this one's a little bit more difficult. So we have z squared is equal to r times the absolute value of z squared minus 4. Okay, so very similar to what we had last time, but here we've got this r in front here. Okay, so we need to deal with that. Okay, so same as before, we're going to make the substitution z is equal to x plus ry. Okay, general complex number z, and then we'll see what the constraints on x and y are. Okay, good. So let's substitute. We're going to get z squared, that's x plus ry squared, is equal to r, don't forget that in front, absolute value of x plus ry squared minus 4. Okay, so let's do the left-hand side first. So we're going to get x squared plus 2 times I xy, and then r times y, all of that squared, is going to be minus y squared. That's equal to r times. The absolute value of x plus ry is going to be the square root of x squared plus y squared, but we're squaring it, so we just get x squared plus y squared. And then the minus 4. Okay, so let's take everything over to the left-hand side and make it all equal to 0. So we're going to get x squared plus 2ixy minus y squared minus ix squared minus ry squared plus r times 4 is equal to 0. And we know that that 0 is actually a complex 0, okay, because we've got real parts and imaginary parts to deal with. Okay, so let's collect the real terms to one side and then the imaginary terms to another. So the real parts will be this x squared minus y squared. Those are real. And then everything with an r, that's going to be part of the imaginary part. So we're going to have plus r, 2xy. We have a minus x squared. We have a minus y squared. And we have a plus 4. All of those come with an r. Okay, good. So now we can highlight that this first part is our real part. The second part, that's our imaginary part, is equal to 0. So again, if it's equal to 0, that means the real part is equal to 0 and the imaginary part is equal to 0. So that gives us 2 equations to solve. So the first one, we get x squared minus y squared is equal to 0. And the imaginary part must also be 0. So we have 2xy minus x squared minus y squared plus 4 is equal to 0. Okay, so let's go back to this first bit. X squared minus y squared is equal to 0. That's going to be x plus y, x minus y is equal to 0. Right, that's just dots. So we get x is equal to minus y or x is equal to y. So that's the real part taken care of. Now for this imaginary part, let's multiply through by minus 1. So we get x squared minus 2xy plus y squared minus 4 is equal to 0. Okay, so why did I do that? Well, now this x squared minus 2xy plus y squared, that is just the expanded out form of x minus y squared. Because if we expand this out, we're going to get x squared minus 2xy plus y squared. That's what we've got on that second line there. And then the minus 4, we can take over to the other side. That becomes a 4. Okay, so this gives us two possible solutions. So we get x minus y is equal to 2. Okay, 2 squared is 4. Or we get x minus y is equal to minus 2. Right, minus 2 squared, that's also 4. So we've got, let's put the or here. So we've got this two sets of equations here. X equals minus y, that's, or let's just sketch this out quick. So x equals y, that looks something like this. X equals minus y, that's going to be something like, that's going to be something like that. Okay, so we've got two straight lines over there. On this other side, we've got two lines again. Well, we can rewrite it in terms of y equals mx plus c if you want, but we end up with two lines like this. Okay, so you can try to sketch them for yourself to see what they look like. Now, to get the solution, we need this first part and the second part to be true. Right, so that means we need to find the intersections of these two lines over here. So this line over here is going to intersect these two lines at 2 points. So we can just substitute in. So x equals minus y, we substitute it in, and that gives us the two intersection points. Okay, so you can try that out for yourself if you don't see it immediately. But if we substitute x equals minus y, we're going to get two possible solutions. One of them being x equals minus 1 and y equals 1. That is the one intersection point somewhere over there. And on the other side, we're going to get x equals 1, y equals minus 1. That's going to be somewhere over here. Okay, if we imagine the intersection points there. So for this first intersection point, remember x corresponds to the real part, y corresponds to the imaginary part. So we can write this as z is equal to minus 1 plus r. That's our first solution. Or, so we've got another solution, x equals 1, y equals minus 1. So that means z is equal to 1 minus r. And these are our two complex solutions. Again, they're complex because we've got this imaginary r for both of those solutions. Okay, so both of them are complex. If we got something like z equals 2, then that would be a real solution. Or we could imagine that as a complex solution, but the imaginary part is just 0. Okay, so either way, you can think about it like that. Okay, but here these are definitely two complex numbers. Okay, so that's everything for today. We'll be doing some more examples later on in the week. Okay, but this is just an introduction to solving complex equations by understanding that these complex numbers have a real part and an imaginary part, okay, to them like we did here, and we can treat them separately. So we've got the real part, the imaginary part. If your total complex number is equal to 0, we know that the real part must be 0 and the imaginary part must be 0. And we can use that to figure out what x and y should be. Okay, so we'll carry on with this next time. If you do have any questions about what we've done today, then you can post a message on the WhatsApp group. You can email me. You can also ask the tutors for help. Okay, they're available on the class group as well. Okay, and remember that we've got the test tomorrow, okay, class test 2. If you do have any questions about that or the practice test that I put up, you can email me as well, or you can put a message on the WhatsApp group. Okay, so one of the tutors will be doing like a little revision in the morning during that Zoom tutorial period, and then we'll have the test in the afternoon, okay, as usual. Okay, so good luck with any revision that you still have, and please ask questions if you have any. Okay, I'll see you tomorrow in the tutorial period.